Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Chang, welcome to the Analytics Engineering Roundup. It's great to have you.
Thank you, Tristan. Super thrilled to be here.
I can't help but notice, so we're recording this on Halloween, and I can't help but notice that you have a costume on. Can you describe, for anybody who's listening on audio, can you describe what your costume looks like?
Well, my son is obsessed about Pokemon, so he's dressed up as Charizard today, and he made me promise that I'm gonna dress up as Ash Ketchum. And this is actually my AirPods case, which is a Pokeball.
That's pretty cool. How old's your son?
He's 8.5.
8.5. Okay, my kids are 7 and 5, and they're just starting to get into Pokemon a little bit, but I don't think they like really fully understand the universe, and they try to ask me questions about it. And I like didn't do Pokemon when I was a kid. Like I was too old for it, and so I can't really help. Like, are you watching the movies with him?
I'm watching the movies, and I'm actually enlisting AI as my help. So my
Nice.
son is obsessed, asking me like, if I put up this Pokemon and this Pokemon, who would win? And at some point, I was just like, "Here's an iPad. I've installed ChatGPT. You can ask ChatGPT who would win."
We found that ChatGPT is a very effective Minecraft helper in that way. I'm just like, no,
Same
I
way.
actually don't know how to build a bucket, but I bet I know who does. Um, okay, so I think you didn't come here to talk about Pokemon or Halloween costumes. You are the founder and I think creator of Lance, the file format, and LanceDB. I would love to maybe before diving into vector search and vector databases, which is where I think we'll spend a lot of our time, just learn a little bit about your background. Like where have you been in this in your like multiple decade long career as a data person, and how did you find your way to this problem space?
Yeah, absolutely. So I love being on this podcast and talking to like analytics engineers because that's actually kind of my background. I started out my career about 20 years ago in quant finance. And the first few years that you're a junior analyst, you're doing all the data engineering and analytics work. And that was what got me into open source Python. And I became one of the co-authors of the Pandas library that way, just solving my own problems of, hey, I don't want to be doing analytics engineering in like Java and VB script. I want to
Wait,
do
so
it something.
you worked for like a hedge fund or something like that?
Yeah. So I
And
worked for a hedge fund called AQR.
AQR,
And
and did they know that you were contributing to Pandas? Like hedge funds are not, I think, widely known for their contributions to open source.
exactly. So my roommate and colleague at the time was Wes McKinney. So one day he showed
Ha!
me this thing. It was like, hey, look at this proprietary like Python library I'm working on. And I'm like, oh my God, this is life changing. And I started using it, working on it with him. And then he spent, I think, 6 months convincing the fund to actually open source it. So they were actually sort of ahead of the industry that way. At the time, this was 2000, maybe 2010,
Hmm.
and the
Did
hedge
Wes
fund
also
industry.
work for AQR?
He did, yeah. And so
Funny. Okay.
Pandas was started there.
Did not know that. That is a really fascinating piece of history. Okay, so a lot of your kind of circa 2010 uh, data code prep work and analytics work was done in like early versions of Pandas.
Yep, exactly. I think we went through several iterations, and I think there were a few weeks where we're like, what are we going to call this thing? And I think at the end, because this was a hedge fund, it was a lot of econometrics, and so
Mm-hmm.
everyone was obsessed with panel data, and so Wes decided to call it like Pandas for panel data analysis.
Huh. It's really stuck. I bet you not a lot of people know that, like, where the name came from. I had no
Yeah,
idea.
sort of a obscure history.
Okay, so you then went on to found two different companies. One of them you sold to Cloudera. You were at Cloudera in a very interesting time.
Right. So Wes and I created this company called DataPad, and it was Cloud BI. Before Cloud BI sort of took over, and we ended up selling that to Cloudera. So I was involved in the Hadoop land and big data for about 4.5 years or so. That's actually where I met my current co-founder. Is he was working on HDFS at Cloudera, and we have a number of ex Cloudera folks at LanceDB today as well. So working on big data at the time when it was Hadoop was the thing, and then I think the my next job was actually in machine learning. So I went to a company called Tubi TV. It was doing
Mm-hmm.
streaming, and
Wait, during your entire time at
yeah.
Cloudera, were you involved in, so the Cloud BI tool was acquired? Were you working on that the entire time that you were at Cloudera? Or did you get your fingers in other stuff?
No, I ended up working a lot in like data governance. So I worked on the governance product and metadata product at Cloudera. So we ended up using Solar
Mm.
to store knowledge graph relationships of people's database schemas. So across all of their different tools between like Hive and Impala and Search and all of that, where is your data? And if you delete a table here, like does it affect any of your business critical tables or processes downstream?
Okay, so from Cloudera, you went to be VP of Eng at Tubi.
QBTV, yeah. But the team was small enough in the beginning where I ended up the architecting sort of the machine learning stack there. So for recommender systems, the machine learning serving infrastructure, and then also experimentation, A/B testing infrastructure. So I had a ton of fun doing that, and I that's where I sort of got exposed to this. Hey, there's a whole world of embeddings, and we were in streaming, so videos and poster art, images, and synopses. None of this data fits really neatly into like Pandas data frames or even Spark data frames, and that's sort of my original inspiration for, okay, we need better data infrastructure to handle this new types of data for what is now people call like classical machine learning. And so I started LanceDB basically because of my experience there.
Okay, so this is our bridge to vectors. Um, because you experienced this problem set at 2B, and I think that was like directly prior to founding the company. Is that right?
Yeah, yeah, yeah. So
Okay.
and at Tubi, I think at Tubi we were also really big users of DBT as well.
Is that
So
right?
thank you for creating that. It's a huge it was a huge help for us at Tubi, and it was a really critical part of the stack.
Thank you, thank you. And that's great to hear. I will want to, by the time we wrap, circle back around to the topic of DBT and how to merge these two worlds together. But before we get there, okay, so many people outside of the computer science world had never really heard of the term vector outside of like algebra 2 way
Right,
back in
right.
the day, and we had kind of like safely archived that to long-term storage in our brains, and then in gosh, I can't even track the timelines now. Was it the end of 22 that ChatGPT came out?
It was, yeah.
Yeah. And then so in early 23, RAG started to be like this thing that people were kind of becoming familiar with, and vector databases were a thing that everybody wanted to talk about, but nobody knew what they were. But I got more deeply into this space via an intro to uh, a founder building in this space. His name is Daniel. He works at a company called Superlinked, and he used to be an engineer at. Do you know Daniel?
Yeah, I know Daniel. He's a great guy. Yeah.
Yeah. So he used to work at YouTube. So like kind of similar
That's right. That's right.
experience,
Yeah.
video, and he actually said that like vectors, although most people don't realize this, are highly, highly relevant for fields outside of large language models. Like RAG is just one of many use cases. So maybe you could give us kind of a non-technical introduction to vector. I want to talk more about the like similarity search and all that stuff too, but just like what are vectors used for?
Yeah, absolutely. So I think maybe like we can step back a little bit to talk about kind of the context and the motivation. And I think especially this is something that your audience being analytics engineers are going to understand better than many others. So I think a lot of the industry and the market around AI is coming into this with a okay, oh my god, we have to have the latest model, we have to have the latest techniques, and that's the only thing that matters. And my perspective is actually kind of the opposite: is that advanced models are great, advanced agent techniques are great, but everyone knows them. Everyone has access to them. So, like, if you're building AI features for your company, how do you differentiate yours from your competitors, right? And I think the answer is the same as it was pre-AI, which is the answer is your data. It's your data that differentiates you from that of your competitors, and how effective you can be at managing your data for AI and connect your data to AI is that critical piece that ultimately is going to be the what is the difference between like just a commodity versus like a highly differentiated product. And so this is kind of
No
where
argument there.
yeah, exactly. So, and I think this is where vectors come in is that vectors are a way to essentially to represent any kind of data in a consistent way that the model can understand. And so, typically or specifically, vectors are high dimensional arrays of floating point numbers, and by high dimensional, I mean like 1,500 dimensions or 3,000 dimensions, right? And so it's kind of like if you were building early days, if you're building a statistical model, your model might be something like 2 or 3 dimensions based on like gender and age and like shoe
Mm.
size or something. And now it's just because AI can understand so many dimensions, you can have these super high dimensional representations that where each dimension isn't necessarily like extremely interpretable most of the
Okay,
time,
so
but
I
they're
want
just
to I
there.
want to get there for a second in a second, but like just so RAG is a use case for vectors, but like what are the other kind of most common use cases that vectors are used for in this world?
So there's a set of models where the vectors and the embeddings are part of the internal representation
Hmm.
within that model. So that is that is part of it. Number two is for recommender systems and for
Right.
personalization. That's actually probably the original use case for vectors, even
Because
before
all of a sudden
RAG.
it's very similar to, or sorry, it's very easy to do similarity search if you have a vector representation of a piece of data.
Exactly.
But then uh, I think just search is also a good use case for vectors too, right? But this
Yeah.
is different than like kind of it's not just like full text search. Like how is vector search different than like pushing command F on your browser?
That's a really great question. So if you look at full text search or kind of like Elasticsearch type of use cases, I think the example I always love to give is like if you search for customer, Elasticsearch is great at giving you documents that contains customer or customers, but maybe your documents contain like user or adopter, early
Mm.
adopter, or company or organization, or things that are semantically similar but aren't syntactically similar enough. So this is where vector search and vector databases come in is you have dense vector representations that create relationships, semantic relationships, where these semantically similar words will live closer to each other in this super high dimensional space. So when you search
Mm.
for customer, you get similar results that contain these other similar words coming back.
Would you commonly combine vector search with full text search in order to, and you would like combine those result sets to get like a complete result set? Is that?
Yeah, so I think and I think this was a journey. So when vector databases first, and when ChatGPT and RAG first became a thing, it was always easiest to say, okay, I'm not going to think too much about it. I'm going to chunk off my documents and just do vector
Mm-hmm.
search.
Mm-hmm.
And it was easy and quick to build that first application or that first demo. And I think we're a couple years out, and a lot of enterprises are now are building things that need to work really well in production. And so
Mm-hmm.
we see a lot of folks are like, okay, either with like maybe they started with full text search, or maybe they just went straight into pure vector search, and they're like, that gets us maybe to like 70% or 80%, and we really need 95% to get to production. And so this is where that combination comes in. It's typically, we call it hybrid search, so you can
Mm.
run
Okay.
search along both methods, and then there's a re-ranking step afterwards that then combine the results and resort them and try to get even more relevance out of your answers.
Before we get to Lance and vector databases and all of the kind of infrastructure behind it, um, you kind of mentioned there that maybe the original somewhat crude approach was my context window is short and I need to get the relevant context into that context window. So I'm going to do RAG, and that means that I can just kind of do full text search and shove it into the context, and I'm kind of good to go. But then your vectors are almost like pretty simple. They were just chunk up the text, shove the text into a vector, you're kind of done. But my understanding is that that's not how vectors are built when you are like a little more thoughtful about it, whether or not it's a RAG use case or like a to be, recommender uh, vector. Um, the is this is it analogous to feature engineering? Like you're kind of constructing your vector to get you the best result.
I think there's a lot of overlap, and so a lot of times there's a lot of there has to be a lot of feature engineering, and really it's about thought that goes into how you construct the data that you give to the embedding model to produce your vectors, right? So some examples might be, hey, the chunk you chunk up your text, but a lot of times the answers that you want um, is it has to have high level context about the whole document, or at least the whole section, and also the particular chunks of text. And so you can do feature engineering tricks where you can summarize the entire document, or at least the entire section, and then that each chunk of text would contain both that high level summary and the individual chunk of text, and then that's the thing that gets embedded, right?
Hmm.
Or you might have more than just text. If you're thinking about multimodal data, you might have images, or videos um, that are being generated, and you might want to extract. Well, I want to extract like an artistic description and a literal description, and I want to
Hmm.
extract tags, and some combination of that gets embedded. Or I might just create multiple vectors and multiple embedding columns, and I can search along all of them and have again a hybrid search and re-ranking step at the end, so that I can maximize the relevance of my results at the very end. So so the short answer is yes, you're absolutely right. There's a lot of feature engineering that can go into a high quality retrieval product before the embedding step actually happens.
Let's talk about vector file formats with Lance. Let's talk about vector databases with LanceDB. Um, I think everyone that listens to this podcast, let's just assume that we understand databases, that we even understand column-oriented databases. Um, I think that the concept of a vector database is something that many people have heard about. I guess my like very high level and crude belief is that a vector database is kind of a standard database with additional index capabilities. Is that a true statement, or am I completely oversimplifying?
I don't think it's overly simplifying, and I think this is where this is probably my hot take is that so one is I think with LanceDB we're creating in Lance format what we're creating is not a vector database but a
Mm,
lakehouse for multimodal data, which includes vectors.
okay.
I think vector databases as a new category in general, it's mostly only optimized for vectors and has an index on the vectors, but it's actually not that effective with dealing with other types of data and other types of workloads. So I think as a category, it needs to evolve and either sort of become a new generation of search engines or become a new generation of lake houses like we are.
Was this
And
always true, or is this a belief that you have come to over the last couple of years?
well, I think this is always true from where I stood. We actually set
Mm.
we actually set out to create the overall kind of lake house vision from the very beginning. Uh,
Huh. Okay.
that the vector database piece is a slice of it that just happened to get the most usage or attention in the past couple of years because of AI and RAG.
Got it. That's so interesting. Okay. Well, then we can come back to that then, but let me get you to outline your vision for the AI enabled uh, data lake. I certainly have absorbed a little bit of this from your website and blog, but you know, I am uh, I'm very familiar with Snowflake, pretty familiar with Databricks. Databricks has really popularized the concept of a lakehouse. Um, what? How do you see the world differently than a company like Databricks?
Yeah, yeah, very much so. So I think as you said, I'm going to assume kind of the audience understands like, parquet and iceberg, or at least are like familiar enough with those terms. And certainly, like my co-founder Lay and I, we didn't start out saying, okay, we're going to create a new file format. In the beginning, that was an idea, but we thought that was like the craziest thing we could do because like, oh no, everyone's going to use parquet. So we tried actually uh, we tried for months to get all of the use cases and workloads that we want to support. These include search and training and data preprocessing for AI data. We tried to get all of that working on like Parquet, and
Mm,
we just couldn't do it. And then I ended up going to computer vision forums, and like we went to GitHub repos and Slack communities, and I just tried to talk to anybody who would talk to me about how they manage their AI data, and the answer was the same. Like there was no everyone tried to do the same that as we did, but no one was able to actually come up with something that was effective. And then we kind of then built confidence to say, okay, maybe we're not so crazy for wanting to create this new format. And so at the core of it is you just like in analytics engineering, okay, you might want to do AI now. So I need to manage vectors like you said, right? And then I probably have lots of documents. These are long text. I might have images and videos. And the first problem I run into is storage in Parquet, and I'm going to run into out of memory issues. Or if I mess with like row groups, and it's gonna either like run out of memory, or like I'm gonna have really bad read performance. And storage is that first big problem. And I'll pause
so
here. I think you have a
I
question.
don't. Yeah, I don't. I have a pretty good mental model of like what a Parquet file looks like. The partitions and column orientation and all this stuff. But most of the Parquet files that I will have ever dealt with will be structured data, and so I actually have no idea what it looks like if you want to put a JPEG or an MP4 or whatever into, like, are you, if you've got a data lake and you've got a bunch of video files, are you
Right.
literally putting them into some kind of blob column inside of a Parquet structure?
Yeah, yeah. So if you have, let's say if you have images, right, you can just put the bytes as like a binary column.
Hmm.
And so we use Apache Arrow as sort of the overall type system. And
Yep.
so these will be large binary columns in arrow types. And same thing with like audio files and video files. Uh,
Hmm.
and for vectors, they're fixed width list columns. So there's it's 15. Every vector is going to be the dimensionality is determined by the embedding model. So 1536 or 3721 or something like that.
And so when you went to try to do this, whatever it was, like 4 years ago or something, what were the kinds of problems that you ran into in the Parquet only universe?
Yeah. So number one was, if you have a Parquet file that has both like really wide columns and narrow columns for like the metadata, you typically the default row group sizes in Parquet means you're running out of memory all the time. So if so you're writing one row group at a time, and with large blob columns, one row group is going to be like gigantic. Or if you really tune down your row groups to like one row per row group, then your like read performance is going to suffer a lot. So
Mm,
that's the first bottleneck that you run into.
mm,
Then even once the data is in Parquet, with AI you want to do search, right? And so you like maybe so one is like Parquet doesn't necessarily have good secondary indexing, but even if you had the index, Parquet doesn't support random access. So to read out the rows that you want that are strewn across the table, um, for each row you have to read out the whole row group. And for like scalar data, it's not the end of the world, but if you have to read out 1,000 or 10,000 images to get to one of them, that's prohibitively expensive. So, and that turns
which
out to
is a
be,
common use case.
yeah, exactly. Exactly. So that turned out to be like really critical, not just for search, but also for data loading during training, for example, where you want to be able to do things like, do like a global shuffle of your data. So your model is not seeing the same
Mm,
data
mm,
in the same order at the same all the time. And it's also really useful for data evolution, where like if you look at, and this is where we go above Parquet into like Iceberg. So um if you want to incrementally add feature columns, right, as you do feature engineering, with Iceberg, it's not easy to do backfills. So if you want to do backfill, you essentially have to
mm,
copy your whole data set, right? And again, this is one of
mm,
those things where if you only had scalar data, like copying a table isn't the end of the world. But if you have a petabyte of images or videos, you really
mhm,
don't want to have to copy the original data. And so those were all the problems that like we ran into trying to solve the trying to store new data types and trying to solve these new workloads on
hmm.
Parquet and Iceberg.
This is like many seasons ago now. This is probably like in season 1 or 2 of this podcast. I spoke to Julian Ledem, who was very
Yes,
involved in creating Parquet way, way
that's right.
back in the day. Um, and it is funny. You you become so used to these foundational technologies. I mean, Parquet is, I mean, it's just like a foundation for how basically the entire data ecosystem
Exactly.
works at this
Yeah.
point. Um, and you kind of lose sight of the original design decisions behind it, because they're so like dusty and off in the past. But yeah, like Parquet and the entire kind of Hadoop and then cloud analytics database ecosystem were all based on a certain set of access patterns that all came from kind of batch-based data ingestion and analytics workloads. Um, and there's no particular reason to believe that those trade-offs would be the correct trade-offs to make in this new world.
Exactly. Exactly. And a lot of it is, So I think I was at Cloudera. So originally, like Parquet was created as a collaboration between Cloudera and I think Twitter folks originally. That was
Hmm.
like the core groups. So you're absolutely right. It's like it really is designed for analytics and OLAP types of workloads on scalar data. And even originally with Parquet, it wasn't even designed for object storage. It was designed for like NVMEs in these like Hadoop clusters, and that cloud storage optimizations actually come in later as well.
The first thing you built then is Lance, a file
Right.
format.
That's
Is that
right. Yeah.
right? Okay.
Yep.
And I was looking before we hopped on. Lance has something like 5.9K stars on GitHub, so it's like certainly developed a little bit of a following. Um, do I don't know like who uses file formats? Like kind of vendors need to choose file formats because then they then need to deliver features on top of them. But like,
Right.
is is Lance like adopted by users or vendors or who uses it?
Absolutely. It's both. So I think number one is there are a number of frontier labs today
Mm,
that are using lands to store all of their training data. So, if you look at like runway ML that does video generation, world labs, and Luma. So a lot of these frontier labs that are at the forefront of, okay, we're going to make models to generate images and videos. They need to manage tons and tons of multimodal data, so they use Lance to do that. And typically they use Lance to replace a combination of something like TF Records, Web Dataset, Parquet, and BigQuery.
hmm, hmm.
And
Okay.
then the other bucket is the big technology companies and vendors. So, Databricks, for example, ByteDance, Tencent, Alibaba, and then I think recently we added like Netflix and Nvidia and Uber as well. So these are all folks that are building on top of Lance format and contributing back as well.
Databricks is using Lance.
Yeah, they're for part of their offerings, or like
Interesting.
AI specific offerings.
Yeah, yeah. Okay. Um, so you as a you first fundraised what 2, 3 years ago, something like that.
Yeah, so we've had 3 rounds of financing. So we were part of YC in the very beginning, and when we first started the
Yep.
company, and then I think we just announced our latest round, which is in back in June, which is our Series A.
Congrats.
Thank you.
Um, the I hear in San Francisco there's VCs on every street corner who are handing out. You just have to be an AI company. No, kidding, kidding. The the tricky situation that you are then in, having created a uh, pretty well adopted file format that's open. So I think it's Apache 2, right?
Yeah, yeah, yeah. So the file
Yeah.
format is totally open source, and it's Apache 2 licensed.
Okay. And you then have to turn around and figure out how to sell something on top of that, which is interesting in a world where the open source thing is widely adopted in the vendor ecosystem. Do you consider these large vendors that are adopting your open source thing to be competitors? How are you thinking about your commercial offering?
Absolutely. So our commercial offering is the data platform that is for sort of really large scale production workloads on AI. So this includes the vector search, and then data pre-processing engine, a cache for training, and serving as well, and then also actually an analytics engine for data curation, data exploration, all that. So that's sort of the platform is designed to say you have a workflow for um, model training, or you have a workflow for AI application development, and we solve the biggest scale and distributed systems challenges along the way. Um, I think
It's
and this is
it's
all
not
optimized around. Sorry, good.
it's not, nothing if not ambitious.
Right, right. Just a small vision, right?
Right.
So we partner really closely with these large vendors that I listed. We don't see them as competitors at all, and mostly because even when there are overlap in sort of features, typically we're not going after the same customer base or geographic regions, or the sort of overall philosophy tends to be different about so like some of the cloud providers that adopt Lance format. Well, they're the goal for them is to get more consumption on the platform rather than have a sort of a data platform that's optimized for AI workloads that serves the AI customers, right?
Hmm.
And other things where like um, you know going after frontier labs is different from going
Hmm.
after a like a global 1000 enterprise or something
Yes,
like that.
totally. Have you found that very AI forward companies, whether you're talking about frontier labs or whatever, just like advanced digital native companies, um, are open to using your commercial offerings? I've personally, experienced the not invented here syndrome that often happens at, very technically sophisticated engineering organizations.
Yeah, 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 absolutely. Well, I think I think a couple of things. Like one, especially with the companies that we work with, the overriding priority is speed. Is like
Mm,
what is the quickest way we
mm,
can get to that goal of maybe it's a model quality goal or like an application shipping time deadline. And I think it's all about like what's the quickest way for us to get there. And maybe it's faster for us to build, but typically it's something like we solve the underlying infrastructure challenges for our customers. So it's not to replace their engineers, it's that so that their engineers can actually focus on higher value added activity. And I think the um to me it's like we're working with companies not so large that there's more people than like really interesting and meaty technical challenges that make a difference. And so I think we see that a lot. Like if we are shipping and we are staying close to the use case and our infrastructure, hey, we know Lance format the best. We know their our customers challenges really well, that we can offer we can just solve that problem without them having to spend time building it themselves around Lance format or another open source project.
the commercial product is called LanceDB, correct? But you actually would prefer to position it not as a database. You
Yeah,
you
I'm not an expert on naming of things.
okay, got it. I think that it's always nice to learn as you record. But I think that probably formed some of my preconceived notions about the product overall. I went to your website and I was seeing messaging about AI native data platforms, and I was like, but also it's a database, right? Um, so this I appreciate this explanation. This makes a ton of sense. Um, I wonder if Lance.com is available.
I
We should
already
do
checked.
it. Okay, so the all all of this makes sense. I would love to I would love to understand how you feel like this space plays out over the next 2 to 3 years. Do you think that um, you know capabilities of uh, the hyperscalers or the data clouds like Snowflake and Databricks start to include the types of stuff that you're uh, uh, focused on today? Do you think that Actually, there's a totally separate ecosystem that can exist here because the AI market is so large and fast growing. Like, I'm just curious, what does the future look like?
Yeah. So I think my vision on the future, especially for the next 2 and 3 years, is based on two, I guess, uh, speculations or predictions. Or so number one is that like we already see a lot of attention on multimodal, and I think multimodal is going to become 100 times bigger
Hmm.
than what it's like today, because it's not
A
just
hundred
about
times,
the
like from a usage perspective or from a file size.
from a usage and like amount of data perspective.
Okay.
So
Okay. Sure.
I think like audio is really blowing up this year. I think we're seeing a
Mm,
huge, another resurgence of video generation as well.
mm.
And I think the next biggest thing that's coming is robotics, right? So just think about how many physical processes there are in the world that can be automated or semi-automated with the right set of world models and robotics combination. Um, and I think it's going to be huge. So multimodal is going to explode like 100x. A number two is that I think the our data infrastructure world um not really ready for agents
Hmm.
that are doing the search and doing the retrieval rather than just humans. So those are the two kind of like huge trends that I think we're gonna see um, be dominant over the next couple of years.
Okay.
And
So let's
yeah,
let's attack both of those.
yep,
Um, I think both of those seem totally plausible from my outsider's perspective. The it is a very interesting difference between the kind of classic structured data ecosystem and the world that you're in, um, because for analytics, every company needs analytics. Like basically, every company of any sufficient size and complexity has people whose job it is to do some type of work with structured data. Um, and, there's laws that say that you have to, like, you can't like be a public company without this. Um, and yet, and so like people who create companies that sell analytics focused stuff, tend to sell into large enterprises because you can assume that everybody's going to have some needs there. But the world that you're talking about is actually a world in which it sounds like some companies need exactly zero of what you're talking about, but then other companies who are very focused on these, like providing these types of products, they need like a lot. Like I could imagine the largest customers or users of a platform like you were describing being like really enormous users of it. Is that a fair assumption?
no, I actually think every enterprise will
You
become a
think so?
multimodal enterprise in the future. Because if you think about it, right, like
Imagine like an insurance company. Like what are they doing with multimodal?
so this is great with insurance, right? Number one, you have tons of insurance documents, right?
Hmm.
You're going to scan them, you're going to extract intelligence out of them, and then you're going to do search and analytics on top of that. But there's a huge portion of that workload is about managing your unstructured data and then extracting insights out of that. Another example with insurance is there are um, new AI native or like AI focused insurance companies or initiatives that are doing things like, okay, I'm doing home insurance and I'm going to fly a drone over
Yeah,
like the
yeah.
area, right? And I'm going to capture the evolution of, fire safety measures and the home improvements and all of that over time. And that's going to make me more efficient as a business. So I think a lot of these businesses are just going to become either existing businesses will become more efficient or new AI focused or AI native businesses within that vertical are just going to clean up because of the
Hmm.
advantages that AI gives them. And a lot of
That's
that really relies on multimodal data.
that's very interesting. I totally see why that would be true. It's also it's a heavy lift. I mean, there's a there's a structured data profession. Like there's people who have been doing
That's
this
right.
for many decades now,
That's right. Yeah.
and um, and so it's kind of a reasonable expectation that every company is going to have like some people that do this stuff. Um, but the world that you're talking about is so brand new that I kind of wonder whether it is going to be true that every Fortune 500 insurance company, and there's a number of them, is going to kind of have their own people doing this stuff, or if there are going to be kind of vendors that package up drone insurance footage products and sell to these. Yeah, I don't know.
I would say there's a little bit of both, but if I think if you go back, it's kind of like you know, like you guys created the analytics engineering thing. Like before that, there wasn't a job title called analytics engineer.
Yeah.
Uh, and and I think it wasn't that companies just like re-educate or like hired new people, educated them to become analytics engineer. A lot of it is um, you know analysts or data engineers or others that are kind of have similar skills, kind of re-educated themselves and repurposed themselves for this particular job role, right?
So
And so I think it's going to be the same thing.
that was going to be one of my questions. When people use your product, like the individual practitioners who are hands on keyboard, um, what what is their most common job title? Data engineer,
No,
ML
it's
engineer.
like, yeah, so it's usually like AI researcher or AI engineer. So the one of the two.
So it's not actually app dev people that want to bring AI use cases to life. It is actually like the team. There's an AI engineering team that is below the app dev people that they end up.
Well, I think a lot of the app devs that are building AI applications are being called AI engineers today.
This is the multimodal prediction. Remind me, what was your second prediction?
Second prediction is that agents are going to completely, like, agents going to be a huge part of the picture, and agents are completely changing how we do search and retrieval. Just kind of like how RAG changed search and retrieval from personalization recommendations. Agents is going to be a next big evolution.
How do agent access patterns inject new requirements on the underlying platform?
Totally. So I think overall the pattern is, with RAG, it's like a one shot, one and done. The human is inputting a question, right? We query the database once, we send it to the model, and you get an answer back. Well, now agents are going through this iterative loop, right? You have multiple layers of questioning that then the agent can keep refining. Number two, the agent themselves, beyond maybe the user is supplying the first question, but then additional layers and additional steps, the agent is actually forming the query, and then refining the results. And so you go from this like one shot, one and done to multiple iterations, and then the load is much bigger, right? Like a human can only type so fast, but an agent can send out like hundreds of questions in parallel and kind of get a ton of answers back and then refine among them. Um, and again, like
and and the types of queries are going to be different. Probably they're not going to be
right.
like trend revenue over time. They're going to be like lots of much more selective queries because they're looking into like one specific thing, and current data platforms are not actually that efficient from a like highly selective queries perspective.
Yeah, and it might be something like, hey, like the human might still be asking, trend revenue over time, but then the agent's like, okay, I'm gonna think about breaking this apart into sub questions and then asking and then refining those answers and forming new questions along the way, and then kind of like coming up with the best answer back. And then also, this is where kind of my two predictions kind of blend into each other. Is that we can only hold so many things in our head and so many ways of think about so many ways to search, but the agent is not limited by that. So the agent can search on, okay, like I'm going to scan my data schema for relevant tables and columns, and then I'm going to generate SQL queries to try to answer the revenues over time question. But I'm also going to search like existing analyses that like and all the other analysts did across the company last week, and like maybe somebody created a chart, and like there's like chart titles and axes titles that gives me clues to like charts that might answer the question. And so the agents actually a lot more can be a lot more creative in the types of data that they're searching on, the types of like search queries that they're doing, and then coming up with really creative ways to actually to combine the results.
I love this because it mirrors one of my personal beliefs about how I get the most value in my own workflow from AI. Um, I find ChatGPT or Claude, like the basic version of them, where you ask a question and then you expect an answer within 5, 10, 15 seconds, to be actually like not that value additive in my life. I don't want it to write me emails. I don't want it to like. There's a lot of things I'm just like, uh, this is not like meaningfully better than I would do myself. Um, but I love deep research. And I love deep research so much because it can do an amount of mental work in the space of like 15 minutes that would
Hmm.
take me like 1 to 5 days.
Hmm.
And
Hmm.
you ask it a question and it will search through 100 plus websites, and it just, and nothing it's doing is like absolute rocket science, but it's just like got a lot more processing than it can do in that amount of time. So I love that you're saying, hey, we are not ready for the volume of requests that are going to happen from agents. We don't even need them to be smarter. We just can expect that they are going to do a lot more mental work.
Yep. Yep, for sure. And then, it's like so number one is like, I think, a bunch of the sort of traditional or older generation vector databases are not really ready for the scale, and the types of workloads. That's number one. And two is just the variety of queries. Cause like the agents can do, you know, like we would have to learn, okay, I got to go learn vector search now, I got to learn photex search, I got to learn like how to manage key value lookups and like pre-filters and how to combine that. The agent doesn't need to spend all that time learning it, right? It can do all of these different workloads and like add filters and limits and do different re-ranking steps. And a lot of times, like if you bring on a new requirement, you just have the right MCP server, the right documentation. You can just kind of generate code for the agent to add that to its skill set toolbox. And so I think it's if we're sort of using traditional vector databases as is, the agentic future is like now you have a infra stack that supports agents, but it has like 5 different databases in it,
Mm-hmm,
and it's
mm-hmm.
going to become a nightmare to like manage all of those just for one agent to be able to have enough richness in the and expressivity to do its job. And that's sort of like part of the reason why another part of the reason why we define design Lance and LanceDB as it is to have, okay, you can put all your data in one place and you just have one system that can do all of the different types of queries that you want.
Common language between all of them is the Lance file format.
Exactly. Yeah.
Yeah, that makes sense. Um, Thank you. This is fascinating. I've learned a lot. Hopefully, our listeners have as well. If for anybody who is has had their curiosity piqued over the past uh, 50 minutes of conversation, is there a one or two resources, maybe on your blog or elsewhere online, that you would point folks to?
Yeah, so if folks are interested in learning more about Lance format, we've got a blog series from Weston Pace, who is sort of our tech lead for Lance format, that goes into much more depth about the format itself, the different encodings and how we design the I/O and the file readers and everything. It's every single one of those blogs that is really fun read, especially for analytics engineers. And I highly recommend that. So it's just lancedb.com/blog, or there's the link from the homepage as well.
Well, Chang, thank you so much for being on the podcast. This is a lot of fun.
Thank you, Tristan. Thrilled to be here. Thanks for having me.